So good morning. On behalf of Group 14, I am going to present how our model works and then what we call what how it works and then through the implementation also. Yeah. So first and foremost, as we are importing these libraries that we are going to need, and yeah, after that, we are going to load the genetics data, the new genetics profiles data that we actually have, and then we are going to clean the column names to remove the extra spaces that are maybe that are in there. So then after that, we handle the missing value. Then for the third step, we are going to convert the obesity risk scores into the categories. For example, we have three categories: low, medium, and high, using the cutoff values. After that, we are going to encode some of the labels, for example, the diet type, physical activity, and yeah, since we are doing this since the machine learning models is going the machine learning model is going to require numeric input. Then after that, we are going to do the encoding. We are going to encode the genetics, the genetic variants. For example, the MC4R variant, PAG variant, FTO, and then the last variant over there. So after that, then we are going to define the features. Those, as you can see, it's called actually features exactly. We are going to define the features. We have BMI, the age, the physical activity, their types, and then the absence and the presence of the different variants. Yeah, then after that, we're going, let me see. Yeah, then we're going to split the data into the train and then test data sets. We are going to use we are going to use 100 trees and a fixed random seed for productivity, and then we train the random forest model. But we are using a pipeline. We are doing it actually twice. We have because we have two data sets. So after that, we are going to do an evaluation of the model. As you can see, we have classification reports and then the confusion matrix. You can actually take a look at them from there. They're already there. I already finished running this. Yeah, then after that, so then going to the second pipeline, which is the main recommendation bit, we'll load the data sets again. By this data set is for the nutritional data. And then after that, we look at, we pre-process the nutritional features. We had chosen these four features: the energy concentration, the protein concentration, the fat, and then the carbohydrates. Then After selecting those features, we're going to encode them using the label encoder and then the target encoder for decoding the predictions. Then we are going to save the model. We are going to use Bento ML. We're using Bento ML to actually save the model. Yeah. And then after that, we are going to the part whereby we do what? So after that, we are going to, after encoding the categorical values and then scaling, we are going to define the model, the meal recommendation model. And this is an example of a profile. That is the profile we expect. That is how it should look like. Yeah, and then this is the function that actually does the prediction, for example, here. But then we should ensure that the user profile actually contains all the features as we've listed them. Yeah, so we get the prediction, and then from there, we can actually get the recommended meals using the two pipelines. Yeah, and then we're going to save the model and then the scalars also. And as you can see here, we have an example for this particular profile. We have an example, and we saved the model, the scalar, and then the encoders. And for this particular instance, we have a precision of high. For the precision that is very high for the high class, low is 0.76, and then the medium class has a 0.71, and then the overall accuracy is actually a 0.78. That is out of 1 definitely. Then that's the confusion matrix we have over there, and then this would be the recommended meal set for this particular instance. Yeah, so and then going into how the model works, and let me switch the screen over here. So this is the hosted model. Yeah, Yes, so this is how it looks like. This is the structure that is given to us, and we can actually check it out. I have an example of a structure that I've prepared over here, and so this is the structure that is given to us, and yeah, as you can see, this is a machine learning service created with Bento ML, and this is the structure they give us. So if you want to get a prediction, you come here in the where there is a post, and then you actually choose you choose predict, and then they'll provide for you a request body. So in the request body is where you put the parameters. For example, what I have. So that's what that is some of the expected input. We expect an age, which is a number. BMI will also be a number. The physical activity, and then diet types, the absence and presence of the different gene variants, and then yeah, that's and then the gene variants themselves. So on pressing execute, we are supposed to receive back, we are supposed to get a result, and let me check over here. Yeah, it's taking a bit of time, but okay. Yeah, so this, as I was saying, this is the predicted obesity risk, and it's quite a high one. As you can see over here, it's quite a high one. And so you're going to get a meal, and for example, the description is butter chestnuts, Chinese matter, and then some raw. But then these are in the energy contributions like 97. Then the protein is 1.4, fats, and then carbon concentration is it's the carbon concentration is 23.94. So yeah, and you can see these are other meals that have been recommended, and they only the top five are actually being recommended depending on what the model has evaluated from the given structure of the data. And I think that marks the end of this presentation. My groupmate Rosla has not been able to be around. She's got some complications at the moment, but yeah, that marks the end of it. Thank you.